Greetings from West Lafayette, Indiana. This is Dr. Jiansong Zhang, and I'm an assistant professor at the School of Construction Management Technology at Purdue University. It is my great pleasure today to talk about my work on using ChatGPT in automated building code compliance checking. And the title today is How Can ChatGPT Help in Automated Building Code Compliance Checking? So this is the outline. First of all, I would like to provide an introduction of the automated building code compliance checking problem and some backgrounds that are related to it. And then the approach that I have taken in this work, the experiment that has been done, and the analysis on the experimental results, the summaries and conclusions, and last but not least, the limitations and the future work. So for the automated building code compliance checking field, the research and development can be dated back to the 1960s when Fimis et al. At the University of Illinois, Urbana-Champaign has digitized the American Institute of Steel Construction specifications into the decision table formats. And since then, there have been a plethora of research and development efforts, both in academia, as you can see on the left-hand side, and in the industry, including those supported by government agencies such as the CoreNet system supported by the Singapore government, and the ResCheck and the ComCheck. These are the software toolkits that can be used to check residential buildings and commercial buildings in terms of their energy performance. And these are supported by the US Department of Energy. And Smart Codes was a project supported by the International Code Council, which is an organization behind the development of a suite of international codes, such as the International Building Code, which is what has been used in my research primarily. And most of the North America jurisdictions actually adopted some versions of the ICC codes. There are also commercial platforms such as Libre, Volvo Software, so on and so forth. So one of the problem of existing automated building code compliance checking systems is that most of the rules that are used to represent the building codes requirements are hard-coded. And hard coding is not very efficient when you want to scale up the system. So the large amount of efforts required in such hard coding tasks, coupled with the large number and the different types of versions of building codes adopted at the different authorities having jurisdictions, in fact, prohibited the automated building code compliance checking systems from easy scaling up, or even prevented the implementation of them in the field in the first place. So how could we solve that? One potential way is to enable automation in the extraction and transformation of building code. So in my prior research throughout the years, we have tested the different approaches in automating the extraction and transformation of building codes, including machine learning-based and rule-based approaches. And based on our previous research, it was found that the rule-based approach, although it takes some human efforts to encode the rules that can be used to transform, extract and transform the building codes into computable formats, it, however, can achieve higher precision and recall comparing to the machine learning translation, as you can see in the numbers here. Since November last year, the ChatGPT was released, and there have been other similar large language models released to the market as well. So the question is, the very powerful large language model-based AI systems can they shift the landscape of the automation research in building code compliance checking? In other words, will the release of ChatGPT and other large language models enable the machine learning-based approach to achieve a much better performance comparing to the rule-based approach? So that is the question that motivated me to conduct this experiment. And the approach that I have taken is an explorative approach, and I comparatively evaluated the ChatGPT in comparison to my semantic natural language processing-based automated building code compliance checking system, or in short, the SNAC system. And the SNAC system has been developed based on more than a decade of research efforts, which enabled automated conversion of building code requirements into logic representations. So in the comparison on the ChatGPT side, I converted the building code requirements into Python codes using ChatGPT. And that was because at the time of the test, the ChatGPT was not supporting the conversion in other logic-based representations yet. And on the right-hand side, I used the SNAC system to convert the building codes into bprolog, which is one implementation of the prolog language. Again, in turn, the prolog is the classic logic programming language. So on this slide, I show an example in comparing the conversion from the regulatory requirement into computable representations. On the left-hand side, it shows the use of the ChatGPT prompt to ask it to convert regulatory requirement directly into Python codes. And the time taken was recorded using an online timer. And on the right-hand side, it shows the use of the SNAC system to automatically convert the regulatory requirement into the bprolog logic representation. And in the end, the results will be stored in a text file like this. So through my experiments, I tested 8 regulatory requirements from the International Building Codes. And these requirements were tested in the increasing order of complexity. So in other words, the second requirement will be more complex than the first one, and the third one will be more complex than the second one. This chart shows the time consumption comparison between the SNAC and ChatGPT. And you can see that with the increasing complexity of the regulatory requirements, the time that was consumed by the SNAC system was relatively flat, whereas the time that was consumed by ChatGPT was increasing. From the quality of the conversion perspective, both conversions actually capture the logic fairly well from the regulatory requirements, and the Python codes did not directly handle the unit of measures in some of the results. And also, it was found that the Python code may not capture the domain knowledge correctly. For example, there was one requirement that was talking about the size of the rebar, depicting the minimum size of rebar should be number 4. And the Python codes directly treated this requirement by representing the number 4 as a numerical value of 4 directly. So in summary, the state of the art in building code conversion research favored rule-based approach, and the recent development in deep learning, especially the release of the ChatGPT, has a potential to shift that landscape. And in this paper, a preliminary but systematic set of tests was conducted on 8 building code requirements with different types of increasing levels of complexity. And my SNAC system, again, it stands for Semantic Natural Language Processing-based Automated Building Code Compliance Checking, was compared with ChatGPT. It was found that the processing time curve by SNAC system was relatively flat with regard to the complexity of the regulatory requirements, whereas the processing time by ChatGPT stably increased. The Python codes generated by the ChatGPT did not explicitly treat the units of measures, and it will require construction domain knowledge to further modify the Python codes to use them in practical building code compliance checking tasks. So in conclusion, the ChatGPT did not immediately change the landscape in building codes conversion research, but it has great potential to facilitate a faster implementation and even scaling up of existing automated building code compliance checking systems by reducing the amount of efforts needed in coding. Limitations of this work: by nature, this is exploratory, and the experiment was only conducted on a few regulatory requirements. It was expected that providing specific domain knowledge to the prompt of the ChatGPT may further improve the results. So I'm planning to test that in the future work. And also in the future work, I'm planning to conduct more holistic testing to compare the precision recall and FM measure of the conversion as well as the building code compliance checking results. Here are the references. And thank you for your attention. If you have any questions, please feel free to let me know. You can contact me at this email at Purdue. Thank you so much.